All right, well, welcome everyone. We're really sorry Gina Raimondo couldn't make it today, but my sincere hope is that she will manage to keep all of us doing our necessary work here with her duties in Washington. So good afternoon. I'm Jeff Brock. I'm the Dean of the School of Engineering and Applied Science, and it gives me great pleasure to bring today the second of our series in the Dean's Invited Speaker Series. These are a new series that we've inaugurated to try to bring members of our community, the larger Yale community, who are highly placed in industry, into conversation with all of you and with the larger Yale community. So many of our alums have made their way to the top of the industrial world in one role or another. They have incredible stories, and our guest today really emblematizes that probably more than any of our alums. So I'm really pleased to welcome C.C. Wei, who joins us in part, in addition to this grand event, to receive the Wilbur Cross Medal this evening from the Graduate School of Arts and Sciences. Let's give a round of applause for that. So just a couple of words about CC's trajectory. He received his graduate degree, his PhD, here in the 1980s, just before I arrived on campus. We just missed each other. And he then went on to a role as a research scientist and working at Texas Instruments Semiconductor Corporation. Ultimately found his way to leading Taiwan Semiconductor Manufacturing Company, or TSMC, which has been in the news and which you no doubt have heard of if you're here. So I won't go through all of the twists and turns of his career and the other academic institutions which may deserve some measure of credit for his arriving at this sort of pinnacle in industry. But really, my goal is to have just an easy conversation with Dr. Wei here and to hear about some recent collaboration that he has been involved in with the United States and how that reflects his worldview. And so, we'll just engage in about 25 minutes or so of conversation, and then I'm eager to open it up to this wonderful crowd. And thank you again all for coming. Now let me welcome C.C. Wei. Okay. Now, maybe you'll turn down the volume for a minute so we can open our Diet Cokes. Exactly. All right, so I have the honor and privilege of opening it up here today, but I guess I'm just curious how you came to Yale, how you saw Yale as a direction you wanted to pursue, and what you think it gave you in terms of your trajectory forward.
That's a good question.
You are wearing the Yale tie, so it must have meant something to you.
Well, starting with this tie. This is the only chance I can wear a tie with proud. I mean, that's if I wear this one in my company, a lot of people will protest, because they graduate from the different school. They think, they are the best. Anyway, Yale is the best. Look, why I joined Yale? It's interesting. This is because of its name brand. You know that what is called a name brand? The Harvard, Yale, and Stanford, MIT, those are the name brand. So when I applied many schools when I want to have a graduate study. And one day I received the admission, and I still waiting for other school to give me the reply. But then my family, my brother especially, he said, "Hey, young brother, this is a Yale. Is that the same as in the newspaper? Is a Harvard, Yale? I say, yes. He said, then what are you waiting for? Just go over there. I mean, I say, well, I'm still waiting for Carnegie Mellon or those kind of a school. He said, what the melon? Melon is a fruit. Don't go over there. So, I accept the Yale. Joke aside, actually, Professor Ma is one of the reasons that I decided to join Yale. And because I have my school professor, Dr. C.Y. Wu, he's a classmate of Professor Ma. And I think that Professor Wu is a nice professor, then Professor Ma must be as good as him. In fact, it's better, it's the best. And I learned a lot from Professor Ma. And today, Professor Ma's wife is here, and I'm grateful to them. Ping Pong. Yes, and then to tell you the truth, when I was, studying Yale, it's an endless work, a lot of pressure, and a long working hour. So I thought that this is the hero of my life. I need to get out as quickly as possible. And I tried, but I failed, of course. You still have to stay 5 years and something like that. And in between, I talked to Professor Barker. We are in the same group. I say, Professor Barker, how can I get out quickly? Then he looked at me, he said, you don't get out. Have you ever enjoyed Yale? I say, how to enjoy Yale? In my life, it's the Haddon-Hartley Hall, the tunnel to Beckton Center, the life in Beckton Center, and never ending. So he looked at me, he said, have you ever listened to any speech in the law school? I said, what the hell? Why I need to? I want to graduate, that's all, right? I mean, that's, so he did not give me the right answer. So I have to be patient. But finally, what I got from Yale is got a PhD degree. But I also very proud to meet one young lady that I fell in love with, and then finally become my wife. My wife is here, Jessica. And then with her, I have 3 lovely kids. Okay, one of them is with me, Terry. Okay, I tell you the truth, I got what I want. I have a degree, I have my wife, and then, the life goes on, right? And I thought that would be a rosy picture ahead, but actually, it's not. If you work on the semiconductor industry, you have to work hard. It's by nature, because of this semiconductor is a very important industry. Finally, we knew that, but 40 years ago, it's not. 40 years ago, EE is not so, let me say that, it's not so popular. Now today is more important. Okay, I got all my story in here.
So I was telling CC earlier that semiconductors are hot. Look at the presence here today. So what would you say about the kind of the American culture resonates with you in terms of developing creativity, productivity? Why might you be inclined to work with the US government to develop this partnership?
That's a good question. Actually, there's a lot of rumor say that TSMC has been pressured by U.S. government to come to U.S. to build a fab. To tell the truth, it's not really that story. In Taiwan, we start to see the limitation. of the number one limitation that in Taiwan I have is the talented people. The limitation of amount of talented people. And to tell the truth, U.S. is a country that with the most innovative, talented people here, like you guys are, okay? Very innovative, very kind of wild driven people, and especially for the Ivy League student, they're always being trained to be the leader. So you guys don't think something small. You will be the leader in your industry, in your career one day. And so now talk about why TSMC want to build a fab in the US. Simple, because the US will have a huge amount of talented people that I can look for. And we can have some select of the talented people to join TSMC in US. At the same time, the US also think about, the government also think about the semiconductor is very important. It indeed is very important because this is a semiconductor is a center of every technology. You name it. In the future, you name it. You want to have a more advanced in medical care, you need a semiconductor. You want to have autonomous driving, you need a semiconductor. You want to have an AI application in every industry, you need a semiconductor. So U.S. government suddenly realized that. I say suddenly because they never talk with the TSMC. Now they talk very often. So I expect to have same occasion that Secretary Raimondo here. But anyway, so finally, why we choose U.S. It's not we choose U.S. This is a natural choice because you need the talented people here, okay? And by the way, U.S. government also promised to help TSMC to build a fab in Arizona. So we choose it, we like it, and we have some problem. No doubt, you just read the newspaper. But then we will overcome all those kind of things. We took it as a kind of a learning cycle, and then we are going to build more fab in the U.S. And welcome you guys to join, by the way.
So you mentioned the characteristics of the undergraduates and graduate students that we train in terms of leadership. What would you see as challenges that universities face now in terms of technical training? What kinds of techniques should we be emphasizing in terms of curriculum?
Technical, that's interesting. I never touched that area for more than 10 years. Now all the days I use my lip service.
Same here, by the way.
That's why we sit here. Actually, my wife joked with me, said that if I cannot speak it out, I can ask my kids to help me to deliver the speech. In undergraduate, let me use one joke. One time I talked with Professor Barker. So Professor Barker said that as a professor, he has to treat the undergraduate student very well because most of them will be the leader in the industry. For the good student, when you have a good track record, when the student have a good track record, they will become professor, so they will become his colleagues. So deal with them politely. When the student with a bad record, the bad score, they will be the industry leader. They will donate the money to the school. So be nice to them also. For those graduate students, ignore them because of, they are useless sometimes. Okay, Now, joke aside, I always think the best Ivy League, so the school, actually to train the future leader. That's very important. I'm not very good at technical, to be frank with you. I'm a mediocre student. When Professor Ma give me the score, that's a mediocre. So I'm the one that graduated, but this school, the Yale, this school, will train the future leader. You look at how many U.S. presidents we have from this school. We are the best in the law school, right? Engineering, I don't know. I mean, that's...
We're getting right?
But then we will be the leaders in the industry. Look at me. I don't need to have a very good score, but, I still can be the leader. Don't worry, you will get it. By the way, the trick is that you have to live longer.
Yeah. So stay healthy. Okay, so you've teed up my next question, which is, at what point when you were working through your career did you see opportunities for leadership? What made you choose to head in that direction as opposed to research and engineering?
Well, the answer is very simple. I'm not good at research. So by nature, you have to choose another route, right? To be frank with you, in my career, we had to be humble. We had to be humble during my whole career. So I know a lot of talented people. They can do much better work than me in terms of technical. But I'm not too bad either, by the way, okay? I have a few papers and about 30 to 40 patent, 30 to 40 papers and speeches, but then I'm not the very best of it. However, during your career, you continue to be humble, humility, and you have to be love what you have doing with your work. That's a trick. That's a trick. You got to be happy. Only when you are happy, you can work hard. But how to become happy, how you are going to love your work, you have to find the pleasure inside your work. That's a trick. If you cannot find the pleasure, don't do it. Change to another company or change your boss. I don't know, usually. But in reality, you cannot change your boss, right? So you try to find some pleasure with your work, and then you will become happy, and then you work hard. I always believe that everybody's wisdom almost equal. You are not much smarter than other people. But working hard, enjoy it, and then you can walk all the way through. And by nature, you will become the leader of your group, and then become the leader of a bigger group, and become the leader of a company, like me right now. To be frank with you, I am lucky all the time, whether you believe it or not.
So your advisor, T.P. Ma, was one of these larger-than-life sort of warm personas, and we miss him dearly. Probably there were nevertheless moments when you had doubts about your chosen direction, as we all do as graduate students. What were the things that kept you going? What can you offer this group in terms of motivation for the hard moments?
Yes, one motivation, because when I was a graduate student, the life is tough, right? I mean, that I had to work for a long hour all the way to the night. So the motivation is to get out of this school as quickly as possible. And then I will have a better life, right?
Yeah.
the same motivation that when I was working in TI, I'm an engineer, so I say, what I am doing, I still work day and night. So I want to be promoted to manager, so I will have a better life. So once I get the managerial job, I say, oh boy, I got to be a VP, so then I can relax. So I was a VP in TSMC. Then I found out, God, boy, I work for a very top boss, Dr. Morris Chen. So I said, oh boy, I mean, I got to be a CEO to get rid of that's a nightmare. And then I start to regret that the nightmare never disappear. So motivation is usually you think the future is better, but it's not really. So just give you a good advice, okay, guys? Be realize that in your life, you always have a dream, and the dream come true, but not the same dream as you have.
All right. Well, I think that's what I wanted to ask our friend, but I'm sure you have many questions you might want to pose to CC. I don't know if there are any hands. Anyone want to raise a question? Yeah, over here. Thank you, Elizabeth.
The vast majority of U.S. military planes have Taiwanese chips in them. And the semiconductors were made in your company. And I'm just wondering where you think the supply lines for these chips will evolve in the coming years. Thank you.
You can either agree or decline to answer this.
That's an interesting question that I don't have a perfect answer. I mean that you are talking about like the U.S. government official talking to me. This is related to the national security or related to the resilience of the supply to the U.S. To be frank with you, in my point of view, this semiconductor industry is globalized. Every country doing what he can do the best. But among them, the biggest, let me say that the strongest country in semiconductor industry is the USA. Okay, you guys don't get misled by the newspaper, by all the rumors say that manufacturing in Taiwan is very good and blah, blah, blah. The strongest country in semiconductor industry is USA. Now, the US is kind of putting manufacturing aside for a while. But if US decide to pick it up quickly, they will. And why I say the strongest country in semiconductor industry is because of all the process, all the technology development. You need the very advanced tools. And all the advanced tools originated or being manufactured in the US. That's where it becomes the strongest. I using the photolithography as one of the example. Today, the most advanced photolithography tool is a EUV. Is anybody know what's called EUV? That's all? And all other people didn't know? Okay, now, let's say anybody who did not understand EUV stands for, except my wife, okay. Okay, good. I mean, that's kind of a very small wavelength tools. And the central part of the EUV is in the US, the light source. the light source to generate such kind of a very short wavelength is from the US. No doubt about it. And using TSMC as an example, I use a lot of applied materials tools. I use a lot of them researchers tool and KLA Tenko and a lot of software from like a mental graphic, or now it become a Siemens, or okay, I forgot their name. I'm sorry for that. But Cadence and then Synopsys and those guys, those are from US. Without them, you cannot develop or you cannot design any product. So part of the reason I can answer Jeff's question, why choose US as a partner? Of course, this is the best country for the semiconductor industry. What years I can choose? So if I have a choice, US is the number one place I will choose. Produce enough chips inside US takes time. Okay, so be patient. That's the same answer I answered that US government officials. Be patient.
Be patient. Okay, there's another one over here.
Hi, I'm Frank. So my question is, even though U.S. is one of the more higher tech countries in the world, what made Taiwan such a fertile ecosystem for TSMC to develop there versus being in the U.S. originally?
Oh, you're talking about the ecosystem for the whole manufacturing of the semiconductor? The same answer, be patient. It takes time to build up, right? I mean, TSMC has been in Taiwan for 30 years. The whole ecosystem, including to set up a building, to set up a fab, the construction worker, to be specific, and also the facility worker and everybody, and also the chemical supply, the raw material supply. It takes Taiwan for more than 30 years to be mature. And so I would expect, I don't think the US needs 30 years. US can catch up quickly because of this is the best place in the world that you have a lot of talented people. And all the key is talented people. And so when US decide to focus on the semiconductor manufacturing, it will be catching up quickly. And but it takes time. It takes time, not 30 years, of course, much shorter than that.
All right, next question.
First, I want to say thank you very much for coming. It's really a privilege to be able to listen to you. I also ask, so since you made the transition from being an engineer to a manager, how did you know, do you have any advice for being able to make that transition from managing circuits to managing people? And do you have any advice with regard to that?
Tell the truth, managing people is very tough. You might want to read a book that's been written by President Salovey. He's the guy who invented EQ. And how to manage the people, please read his book. I regret a lot that I did not read his book and being promoted to a manager's job. I like to manage the machine because they don't protest. Managing the people are very tough because of, for example, if they are not have a quarrel with his wife, then his temper becomes very bad. How did I know? I mean, that yesterday he's my nice, good friend, and today he showed his face on me. So I don't understand that, so I give him a hard time. So usually you change from technical role to become managerial role. you have to pay more attention to people's daily life, which is a very dynamic. And so it's a very tough job. And so if you are a very good manager, I always ask my guy, if you want to be promoted to be a manager, you got to get married. You know how to manage your family, then you will become a good manager. No joke. I tell them that if you are not married, I will not promote you to the manager.
Over here.
If and how do you see TSMC essential in countering China's rising global technological influence and semiconductor industry?
The question is, from my point of view, to look at how China.
Countering China's semiconductor industry and their global technological.
I don't make a public comment on China, by the way. To be frank with you guys, I was not allowed to give a speech without go through my legal department. So I prepare no FOIA because they say that CC, you probably have a big mouth, so we don't allow you to talk about something 1, 2, 3, 4, 5, 6, 7, and then finally I decide I have to keep silent. So I don't make a comment on my customer. I don't make a comment on U.S.-China's political confrontation. I don't make a comment on China. I have a lot of customers in China, by the way. They all use TSMC. And besides, the one being put on the entity list was my second largest customer. And I lost that. But anyway, no, thank you. No comment.
Okay, another one over here.
Hi. So I'm sure throughout your career you've had a lot of like mentors and sponsors. I'm curious to hear like who some of them were and why you picked them out.
I did not catch what
Who some of your mentors were and why you sought them out.
So I pretend I don't understand her question. For the mental work, mentors.
Yeah, like TP.
From the TP Mars, starting from TP Mars first, right? I learned a lot from all my mentors, per se. I have 4 persons in my life. The first one, TP Mars, I learned a lot because of TP is smart and never be harsh on me. Even my academic work is mediocre, but of course, in later days, when I've been in the VP or senior VP or the CEO of TSMC, TP Mars start to change his record on me and become better. But actually, I learned from TP on he's very patient and very kind of instructive. And he also showed me how to write a good technical paper. That teach me a lot. And then after TP and Professor Barker, after TP, I joined TSMC, and there's a talent boss also. In TI, I have my manager is called Roger Hagen. Roger Hagen, he passed away when he was very young, but in the IEEE IEDM has a Best Student Paper Award in name of Roger Hagen. So they call it a Roger Hagen Best Student Award. That tells you that how important he is, his achievement. He's very smart. Usually, do you know that in our life, before, okay, I tell you guys, after you graduate and join a company, you will start to write the weekly report. And nice to be a CEO because I don't need to write a weekly report now. Okay, so I have a long time for more than 30 years, continue to write a weekly report. Roger Hagen is the one that never cut paste on my weekly report into his weekly report. Okay, he read my weekly report. If he did not understand, he called me into his office. And then he asked me to sit right beside him, and he started to use his own word to write the weekly, and asked me to read it, say that this is exactly what you say. And he catch up the idea very quickly. And then one day he became the senior fellow of TI. His job grade is higher than his boss. His boss is a boss, and directly report to the TI president. So that tells you that how smart he is, and he also teach me a lot. He give me a lot of not instruction, but just say, why this one become like that? Why you did not see it? Oh my God! So I have to go back and work hard. Roger Hagen. But finally, I met with a very top one, if you want to call it a mentor. Dr. Morris Chen. He is a founder of TSMC. And I learned from him a lot, but he's still around, so I don't want to make any comment.
So you've spoken about AI and how your semiconductors are necessary for this. A woman in the front spoke about weapon systems and how semiconductors are also necessary for that. Do you think it's feasible to introduce greater tracking of where semiconductors are going, of what they're being used for?
Semiconductor, it's because of U.S.-China's confrontation, so become the center of that confrontation. But to be frank with you, without that, actually, finally the people will realize that semiconductor is a center portion of all technology, including whatever you want to name it, including in our life, like I like to use in the medical as one example. I don't like to use in the military or some kind of a confrontation. In the medical field, I want to make a joke of my wife. She only trusts the guy with experience, right? So when you see a doctor, you want to see an experienced doctor. Am I right? Okay. But look at it. To give you some idea, if a doctor is 50 or 60 years old, are you going to let that guy to do the operation? Do you know that the people's hand is not steady? Do you want to do the experiment? Just hold a laser pointer to the wall and see how steady it is. Okay, now here comes the question. If you want to do the operation, with the hand is some kind of uncertainty, and then you let that doctor to cut it? Not me. I mean, that's I will trust that is everything controlled by the semiconductor, then I will trust it. Okay, so in the future, I would like to say the surgery will be done by the machine. The machine is controlled by the semiconductor. That's one thing. And the other thing is what is called experience. Experience, that means you learn a lot of skill by years. And you have to remember, by the way. So I will say that if you go to the hospital to see You got the flu, so you tell the doctor, say, I got the flu, I have coughing, I have a running nose, and everything, blah, blah, blah. And so the doctor will say, okay, sit right there, measure your temperature, measure your heartbeat, and then be very patient with you for half an hour, and then write down some medicine for you. I don't need it. I just using the AI to correct all the flu example in this area, and then the AI will make a judgment, say that what the age you are is a male or female, and what the symptom, what kind of a temperature, body temperature, what kind of heartbeat, what kind of blah, blah, blah. And then they also look at, are you in New Haven, or you are in New York, or you are in Washington, D.C., and so the flu in that area of the people, the symptom look like a what? And finally get a conclusion and write down the medicine for you. And the accuracy will be 90 or 95%. So you don't need a doctor. You just type into the computer. And then 90 or 95% of accuracy, you still have 5% to 10%, right? Then you see a doctor. And then doctor say, it's not working for this one. And the computer asks, so what years? Type it into. So the computer continue to remember, continue to educate itself. And so finally, I don't need a doctor to see when I have a flu. I don't need a doctor to do the operation surgery. I don't need a doctor to give me some advice, like I'm overweight. And the AI will tell me, say, Mr. Wei, you are overweight for 5 kilograms. You better to do the following. And whether I follow it or not, then I have to wear a smart watch. And then the watch will measure my heartbeat, measure my temperature, send it to computer, and computer give me a warning, say that you are not listen to me, so you have better watch out. You only have how many years to live. Then I'll get nervous, right? So I start to follow the instruction. But anyway, in the future, semiconductor will be the key to in our life, something like that. Yeah.
Okay, maybe we have time for one last question. Yeah.
First of all, thank you for the great talk and inspiring us. Of course, every process in the semiconductor manufacturing is very important, but past decade, people talk a lot about the miniaturizing the semiconductor and integrate more and more chips inside of more and more transistors inside of the single chip. But it's like 7 nanometer, 5 nanometer, 3 nanometer, like that. But now we will facing the limit of the miniaturizing the process. So what is your insight or prospect? Which process will attract people's attention after that miniaturizing and integration the transistors?
Good question. Is there any, actually your question should separate into is there any limitation at all? Okay, and what we are doing to deal with it. I give you a story. When I graduated from Yale, I joined TI in actually at the beginning of 1985. I graduated in 1985, but I want to work quickly because I have a family to raise. So at the beginning of 1985, I work in TI. I read a paper published by the IBM. They call it 1 micron technology. And they say, not for long that will reach the limitation of the semiconductor device. If you look at it, look at the mean-free path of your electron at a kind of different temperature, you'll find out if a channel length shorter than your mean-free path, there's a lot of limitation. There's a lot of high electron. There's a lot of physics inside. So they say, quickly, 0.35 micron is the end of the semiconductor technology. Okay, and since then, now today we are at 3 nanometer. And so the people ask me the same thing. We ask ourselves inside TSMC, is there any limitation? So what happened after 3 nanometer? You know, 2 nanometer. So what happened after 2 nanometer? 1.4. I tell you the truth. You just timed by 0.7. It was so one of the occasion I answer the question, the people ask me, what happened after the 1.4 nanometer? I say 1 nanometer. And what happened after the 1 nanometer? Of course, 0.7, something like that. And they keep asking. And finally, my answer is, why should I care? Because I retire already.
All right. Thank you again, CC.
Thank you,
Real
guys.
pleasure. Thank you for coming.
Thank you, sir.
Please welcome, enjoy some refreshments outside, and let's thank CC here again.
One last word. Don't forget to join TSMC after you graduate.
All right.